In 1801, a simple beam of light broke our understanding of reality. Even today, we still don't fully understand what it means. Welcome to Quantum Consciousness, where we explore profound mysteries at the intersection of science and perception. Today, we delve into one of the most iconic experiments in physics, the Double Slit Experiment. Imagine a screen with two tiny slits. If we fire particles, like electrons, at this screen, what would you expect to see? Common sense dictates they pass through one slit or the other, creating two distinct bands on a detector behind the screen. Much like firing tiny bullets at a wall with two holes. This is what happens when we treat particles as discrete entities. Two bands, simple, predictable, but here's where the universe begins to whisper its secrets. When we fire these same particles, one by one, without observing which slit they pass through, something astonishing occurs. Instead of two bands, we see an interference pattern, a series of bright and dark fringes. This pattern is characteristic of waves, not particles. It's as if each particle somehow passed through both slits simultaneously, interfering with itself. This phenomenon is known as wave-particle duality, a cornerstone of quantum mechanics. This perplexing behavior led to a fundamental question: how can a single particle behave like a wave and a particle at the same time? The answer, or at least a significant part of it, lies in the act of observation. When scientists tried to determine which slit the particles passed through, by placing a detector near the slits, the interference pattern vanished. The particles suddenly behaved like discrete particles again, creating two distinct bands. It was as if the very act of looking forced them to choose a path. This is not an exaggeration or a mystical interpretation. This is pure science, observed repeatedly in countless experiments. The implications are staggering. Pioneers like Niels, Bohr and Werner Heisenberg grappled with these paradoxes. Bohr proposed the Copenhagen interpretation, suggesting quantum particles don't possess definite properties until measured or observed. Before observation, they exist in a superposition of all possible states. Heisenberg's uncertainty principle further solidified this idea, stating we cannot simultaneously know certain pairs of properties. The act of measuring one inevitably disturbs the other. Even Albert Einstein, despite his monumental contributions, found the probabilistic nature of quantum mechanics unsettling. He famously said, "God does not play dice with the universe," struggling with the idea that reality might not be fixed. Classical physics, with its deterministic laws, simply cannot explain this quantum phenomenon. So, if observation changes physical behavior at the quantum level, what role does perception play in our experience of reality? This isn't about making mystical claims, it's about asking profound questions rooted in scientific discovery. Understanding reality may begin with physics, but it inevitably leads us to question ourselves, our role as observers, and the very fabric of existence. Join us next time as we continue to explore the science behind consciousness and reality. Subscribe to Quantum Consciousness to unravel more mysteries of the universe.